Greetings. Here's a 1985 Korg DW6000 synthesizer. This synth arrived at the artifact cave in a complete non-functional state. Didn't even turn on. But let's have a brief look at it. It's not in too bad a shape. Problem is it was dirty as usual, and when I cleaned it up I could see there was quite a bit of paint wear. But that's kind of normal for these because they were heavily used. Now in this one you can see that the control panel is kind of sparse because they were figuring out at that time that it would make more sense to, instead of putting a lot of knobs and buttons on it, and for comparison's sake, here's a real synthesizer, a fully analog synthesizer that has lots of buttons on it that you can twiddle and do good stuff with, whether you're creating sounds or whether you're just live performing and tweaking sounds. But this was a lot cheaper, so they did it this way. It does take away the ability to really do real-time tweaking of the sounds in an effective manner, but it still sounds interesting. They've devoted almost half of the panel to an explanation of what all the parameters do, which is kind of necessary. I mean, maybe not this big, but it's necessary because all you see on the display is going to be a parameter number. These are just numeric 7-segment displays. On this side, they helpfully tell you what the names of the presets were that were originally shipped with it. But since those were battery backed, there was always a good chance that you would have either lost the original presets, or the factory hadn't done a really good job in providing them, and you had to make your own. And that about sums up the synthesizer. Now, what does hybrid mean? I mean, there's two ways, well, there's lots of ways to generate music, but in electronic instruments, it's either digital or analog. And prior to the digital revolution, synths were entirely analog. I mean, the Micro Moog has nothing digital in it. I mean, the closest to digital is probably a 556 dual timer. But this guy has two microprocessors in it. It generates, the voltage-controlled oscillators are actually digitally controlled. The only things that are purely analog in this are, first of all, the filters work in the analog domain. Everything else is really done in the digital domain and then run through digital to analog converters. And of course, what comes out the back is analog, because otherwise we wouldn't be able to listen to it. It's got lots of jacks on the back, inputs and outputs. You can see the trio of MIDI connectors over there, and the power connection back there, and a power switch, and that uses the very safe 2-prong pin with no ground plug on it. So at least on the plug on the other side, half of these things you see, they've ripped off the ground prong because the venue they were playing at didn't have grounded outlets. But on this one they just said, let's not deal with that. We'll just put a 2-prong plug on it and be done with it. So this thing was totally dead. You're supposed to plug it in, well, into power, click it on, and the display should light up, and there's a bunch of LEDs that should also light up. But it didn't do anything, just as advertised. Then of course I hooked it up to an amp through that cable there, and hoping that the problem was that maybe the display section doesn't work. I tried it out, and no sound came out of it whatsoever. First steps are always check the power section. And it's amazing, some people always don't do the first step, and that is measure. Is there AC coming in to the transformer at all? Does the power switch work? But after you get over those simple tests, then you look at the regulator board, and this one's interesting because it's got 3 5-volt regulators on that big heatsink and a minus 5-volt regulator. And then it's also got 12 volts unregulated coming off of the transformer. I mean, that's also DC, it's rectified, but it is not regulated, and that's used for the analog circuitry. So the idea is, let's check all of these voltages. The voltages come out with these 4 connectors in the middle of the picture. We have this first board here is like the general supervisor. It does things like reading buttons and doing a whole bunch of other things that are not directly musically related. It does also manage battery-backed storage of patch data, but it's all digital. We get to the main processor board, which is also all digital, and this is what generates the digital part of the sound you're playing, and also communicates with the all analog board that has filters and voltage controlled amplifiers on it. Other than that, we have the PCBs holding the front panel controls, a chorus unit that is completely analog, and of course the keyboard itself. So I checked all the voltages, and most of them seemed good, but the 5 volts on this connector was reading 3.5 volts. That connector goes to the main digital board here, and the voltage was reading 3.5 volts over here too. So of course I unplugged it. I checked the voltage at the power supply after unplugging it, and the voltage had jumped to 5 volts. Okay, that's a no-brainer. Can't function under load, or there is something shorted on this board, most likely a capacitor. I measured some voltages on the regulator board and was interrupted by a ringing phone. So I took the call and was gone for about 15 minutes, and the board was still powered up. And when I came back, this is what I saw. The instrument had powered up. There was no burnt smell, and the keypad responds, the slider responds, the LEDs change. All in all, it seemed like at least the front panel was working perfectly. However, there was nothing coming out. It's hooked up to an amp, and nothing was coming out of it. Now, the original mystery is, how did this thing fix itself? I mean, ever since it came on, of course, I power cycled several times. It never missed a beat. I left it off overnight. It powered up right away the next day. It just fixed itself. Now, with something like this, it screams, hey, you have a capacitor that reformed, and now it's good. It always works. But looking at the power supply, all 3 5 volts share like the same rectifier bridge, the same initial smoothing capacitors. There really isn't that much in between that one particular 5 volt regulator and the board. Bypass caps or shorted caps don't reform, so it wasn't the board, it was the power supply itself, and it fixed it. And that's the best explanation I can come up with right now. And for those of you getting ready to point out to me what I stupidly overlooked, is, I mean, here it is. Power comes in through here. It has a single bridge that feeds, the positive side feeds all three 5-volt regulators. This regulator was the one being brought to its knees by the load being hooked up to it. There really isn't a whole lot left. The only thing really specific to this regulator are these two diodes, both protection diodes, a resistor, and a 100 microfarad capacitor. I checked them. I took them out of circuit. They were all good. So to me, that is still a large mystery. But if you have any ideas, please let me know in the comments below. The only other thing here is there's a negative 5-volt regulator which is fed from the negative DC output of the bridge, and then they came up with this monstrosity to generate minus 7 volts. But that doesn't affect the 5 volts, or shouldn't. So yes, leave me a comment if you already know what it is. But finally, it has never failed since. I mean, at least as far as powering up. So I was making sound, and I usually start with external checks instead of going inside, because those are the ones that get touched by the human operators, and those are the ones that break a lot quicker than the semiconductors. So I sat here. It's kind of loose, but it's a little loose, not really that much. That didn't do anything. I just applied pressure and did all sorts of things, and it's still open. And all of a sudden, I got some sound coming out of it, which cut out immediately. It turned out that there is a high-low output switch, slide switch right here. And I found that if I jiggled this switch, I would get sound. But the minute I let go, sound would disappear, and even switching it back and forth would just give you crackles. So could it have been as simple as a dirty switch? If you've done switch cleaning, and nowadays everybody immediately goes to deoxit or contact cleaner, and I've been guilty of that too, but one thing that I've learned is start small, because contact cleaner, and especially deoxit, leave a residue. Now the residue is non-conductive, but it's there. It doesn't just evaporate immediately. And it can, I mean, on something like a plug or so, you can probably use it, but if you're dealing with switches and stuff, it will collect inside and may adversely affect functionality. So what I have started doing is isopropyl alcohol is my first go-to. Since it was open already, I sprayed the contact. This is the cheap kind where the contact's the slide switch. It's not enclosed. So the switches are open to the elements. And after giving it a few good squirts, blowing out the alcohol with air and letting the remainder evaporate, the instrument started to work. So remember, this was an 80s instrument, and it sounds, I mean, the patches that they gave you sound very 80s. And, you know, the electric piano was big. Then you had your analog brass type sounds. And all sorts of other goodness. Remember, there's no effects processing on this, no reverb or anything. So it doesn't sound too great, but it'll sound a lot better when you help it along. And then of course you got lots of patches here. So number 67, what is that? Electronic Organ UM. Yep, that's UM, all right. And just a whole bunch of other things, just to show you that it works. It fades away too fast. But yeah, so it works, but there were other things that needed fixing. These buttons were a disaster. When you wanted to change them, some kind of worked, i.e. you had to put your finger on it and rotate it and do this kind of stuff. Some wouldn't work at all. Some would double trigger. Some you had to hit really hard. Unfortunately, the switches used on these are notorious for that. They look like this. Where are you? They're just momentary switches. And dirt gets in. I mean, it goes through the panel here, and it goes and settles inside the switch. And the clean the switch approach I used with IPA for the audio connector made no difference whatsoever. I mean, these things, you can't take them apart, and I'm guessing they're completely encrusted with corrosion on the inside. But you can get these switches. I had a few. Same switch, but this one, I think the color of the top of it signifies the force required to push it down. And yellow, I think, needs a little more force than the black ones, but whatever. The only annoyance here was that the square part fit in the underneath of these switches, and the square part on top on these yellow ones was slightly larger than the black ones, and it just wouldn't fit. I didn't want to force it, so I had to sit down with a nail file and make this part, file it down on each of the faces till it slid in here. But the good part was, once I did that, it came back, it works perfectly. It doesn't emit a single key hit. And yeah, here's what I replaced. Every single button, because it's if the buttons start doing that on this, it's no use trying to fix them or trying to be cheap and saving a switch and saying, hey, this one kind of works, so I'm going to leave it in. So all of these buttons, and of course these three. The pots there are 3 sliders on here. This is a data slider. You can enter the data for parameters either numerically or using the slider. Then the other 2 sliders, here's a volume slider, and here's a slider that says tune, but the shaft was broken off. It still works. Let me get a screwdriver and demonstrate that. If I can find it. But it is not easily accessible, obviously, because the shaft is broken clear off. Let's see. So it functions. The sliders were all cleaned with IPA, but it's kind of a small short throw slider, and haven't found a replacement for it yet. But generally, for everyday playing, you can tune it at the beginning of your session with a screwdriver, and since the oscillators are digital, it will stay in tune for a very long time, if not forever. And that sums up the switches, but there was more. Not all of the keys worked. I mean, it wasn't like the buttons up here, total disaster, where every single one had a problem. But there were about 5 or 6 keys that either double or triple triggered, and I think there were 3 of them that didn't work at all. So I had to pull out the keyboard, and basically it uses a little rubber. Think of a rubber hemisphere with a little carbon dot in the middle of it, and when you press a key, it presses that down on a PCB with 2 contact halves, and it completes the circuit. This doesn't have velocity sensitivity or anything like that. And people usually think that the PCB is the problem. And the PCB had some marks on it, but just cleaning the PCB didn't fix it. It's that little carbon button in the rubber semisphere that I guess it loses conductivity. So I cleaned them all, but some of them didn't work, and I had to help them out with a automotive rear window defogger repair kit, which is basically conductive glue. You just put a dab of that onto the carbon contact that is supposed to connect the 2 PCB contacts, and that fixed all of them. All of the keys worked reliably, so it's back there. And I think there was only one issue left. The last issue was that when I got it, one of the keys had been broken by an overzealous musician and then promptly glued back together. It is solid. It's fine. It is even with the rest of the keyboard. All good. But it looked horrible because they had put a massive glue on there with black streaks in it, really deep black streaks, and it was extending over here and here. It was horrible to look at. But no problem. I went to my parts box and I found this, a replacement key, identical. Unfortunately, when I put the key in instead of this one, it was significantly lower than the neighboring keys. So this thing, I mean, when I bought it, it wasn't new, is worn somewhere. There's no way to adjust the metal on the key bed inside to make this come up or down, or at least no way I could find. And it bugged me because the glue here didn't really affect playability that much, unless of course you press the key over here. A non-level keyboard will affect playability, whereas this may too, but not nearly as much as a key that's hanging lower, like here. Oh, you can't see, but well, that's hanging lower at least a 1/16 of an inch. It was bothersome, but this looked horrible. So what I did was, the key is basically, it's solid plastic. So I filed it down over here. Sure, you can still see it, but you can barely feel it, and it's nothing like it was before. I mean, you could see it from the other end of the room. These masses of glue left over and black streaks and all of that. Most of it came off. I guess I could attempt to paint it. But one other problem with this key is, and it probably won't show up in the video, but the color is different on this. This has a different amount of wear and UV radiation and stuff on it than the other keys. The other keys, no matter how much they've aged, they've all aged evenly. So I think this is a better solution right here. It doesn't bother me that much. It still bothers me, but it doesn't bother me that much. But the thing I learned is even if I go out, I mean, you can't buy new keys. They're all, people will usually port out these keyboards and sell you their keys, and most of them are not going to match in color. Yeah, see here, I think you can really see the difference here. And let's look, I think that looks even worse than this. So this is what it shall be. Thanks for watching. If you liked it, please leave me a like. And if you didn't like it, then don't do anything. Leave me a comment and hit that subscribe bell if you haven't already. And we'll see you next time.